So this is just a summary of the prestress losses that will be experienced by the prestressing reinforcement in accordance to the factors mentioned on the code. So these are the 6 factors, 6 reasons of, or 6 causes of prestress loss mentioned on the codes, specifically on ACI and NSCP, our local code. So let us just study this particular summary of the prestress loss that will be experienced by the prestressing reinforcement. So first on the table is the prestress loss due to elastic shortening of concrete. So we usually specify it as ES. So according to this table, uh, if you will use pretensioning, the prestress loss due to elastic shortening of concrete will occur at transfer for the case of pretensioning. But for the case of post-tensioning, the prestress loss due to elastic shortening of concrete will occur if you will use uh, sequential jacking. If you can remember, we have two types of jacking that we have studied from the previous discussions: the sequential jacking and the simultaneous jacking. So in sequential jacking, the pre-stressing reinforcements are jacked individually, one at a time, while on the simultaneous jacking, obviously the pre-stressing reinforcements are jacked all at once simultaneously. So for the case of post-tensioning, the elastic shortening of concrete, or I mean the pre-stress loss due to elastic shortening of concrete, will just occur if sequential jacking is used. So that is how we can interpret this table. So the next cause of pre-stress loss is the relaxation of tendons, which usually occur in the case of pretensioning before and after transfer. So as you can see on the previous slides, on the early discussion for this meeting, you can see that the uh, the pre-stressing reinforcement, even before the transfer of pre-stressing force from the reinforcement itself to the concrete element, it already experienced losses. If you can remember that what we have discussed a while ago, it already experienced losses. Actually, those losses is actually due to relaxation of the pre-stressing reinforcement. So even before the pre-stressing force is transferred to the concrete element, the pre-stressing reinforcement already experiences pre-stress losses, which are due to the relaxation of the steel reinforcement. Due to the relaxation of the pre-stressing reinforcement. Although this particular cause of pre-stress loss also occur after transfer. So it occurs before and after transfer for the case of pre-tensioning. But for the case of post-tensioning, it usually occurs after transfer. So after the pre-stressing force is transferred to the concrete element, the pre-stressing reinforcements tend to relax, thereby losing some of the pre-stressing force that the pre-stressing reinforcement experiences. Although you have to realize, again, in equation form, these things that I have mentioned can be summarized using this uh, formula here, wherein the I denotes initial and the J denotes the loading stage after jacking. Say, for example, before transfer, after transfer, and then uh, the total magnitude of the pre-stress loss due to relaxation of tendons is actually a sum of the relaxation that happens uh, from T sub O, which is from the time of jacking to the time of transfer of the prestressing force to the concrete element. So that is the first occurrence of the relaxation or prestress loss due to relaxation of the prestressing reinforcement. So that is actually before. That is what we have mentioned here. That is actually the before transfer occurrence of the relaxation of or prestress loss due to relaxation of prestressing reinforcement. But again, after transfer, which is this, the prestressing reinforcement tends to relax again from the time of transfer to the time at stabilized loss. So if you will try to compute for the total prestress loss due to prestressing reinforcement relaxation, it actually has two parts. The first part is occurring before the transfer of the prestressing force, starting from the time of jacking up to the time of transfer. And the second part or second portion of the total prestressing of the total loss due to still relaxation happens after transfer, starting from the time of transfer to the time at stabilized loss. So you can see that the loss due to still relaxation or prestressing reinforcement relaxation is actually a time-dependent uh, prestress loss. Just like what I have mentioned a while ago. If you can remember, we have two categories of prestress losses, the immediate and the time-dependent. So this is actually the first time-dependent prestress loss that the prestressing reinforcement experiences. So another prestress loss mentioned here is the prestress loss due to creep of concrete. Or wait, and that I already mentioned that the prestress loss due to still relaxation happens after transfer for post-tensioning. For pre-tensioning, it happens before and after transfer. For post-tensioning, it happens after transfer. So that's for the prestress loss due to relaxation of tendons. Another factor here, another source of prestress loss is the creep of concrete, which usually occurs after transfer on the case of pretensioning, and also at transfer, or I mean also after transfer for the case of post-tensioning. Although you can see here that the creep of concrete, just like the prestress loss due to relaxation of tendons, the creep of concrete is actually also a time-dependent loss. That's why you can see a time function here, because the creep of concrete, the magnitude of the prestress loss due to creep of concrete is actually dependent on with respect to time. So usually uh, we have to consider the time with respect to the stage of prestressing operation wherein the creep of concrete will occur. So later on, we will talk about more of that further on the following topics, on the succeeding topics. Another source of prestress loss mentioned here is the shrinkage of concrete, which occurs after transfer for the case of pretensioning and post-tensioning. And again, you can see here that it is also time dependent. So its magnitude depends with respect to the particular time, specifically on the particular time in the stage of prestressing operations. Uh, actually, the first four here, the first source of prestress losses mentioned here, are actually the prestress losses being experienced by a member or concrete element on the case of pretension members or for the case of pretensioning. So the first four sources of prestress loss here are actually the prestress losses that are being experienced by pretension members. So if you will try to find the total prestress loss for the case of pretension members, we can have this formula here. So again, the total pre-stress loss for pretension members is just the sum of the losses due to the elastic shortening of concrete, due to the relaxation of tendons, due to grip up concrete, and due to shrinkage of concrete. So those are the pre-stress losses that are being experienced by a pretension member. So again, take note, uh, that is just the case for pretension members. So another source of pre-stress loss that is mentioned here is the pre-stress loss due to friction. So actually, the last two pre-stress losses, or the last two sources of pre-stress loss mentioned here, are just applicable only for post-tensioning. So the friction loss, or the pre-stress loss due to friction, occurs for post-tensioning at jacking, while the last source of pre-stress loss mentioned here, which is the anchorage seating loss, occurs at transfer for the case of post-tensioning. So again, the last two pre-stress losses mentioned here are just applicable for the case of post-tensioning. We don't have this. With this pre-stress losses do not occur on the case of the of pretensioning, or on the case of pretension members. So they are just applicable for post-tension members. So if we will try to find the total pre-stress loss that is being experienced by post-tension members, in addition to the first four sources of pre-stress losses, the post-tension members also experiences losses due to this last two sources of pre-stress loss, which are the pre-stress loss due to anchorage seating and the pre-stress loss due to friction. In addition to the first four sources of pre-stress loss that I have mentioned here. But then again, take note, for the case of post-tension members, take note that the uh, the pre-stress loss due to elastic shortening of concrete uh, will just occur if the tendons or the pre-stressing reinforcements are jacked sequentially. So if the pre-stressing reinforcements are jacked simultaneously, all at once, therefore there will be no pre-stress loss due to elastic shortening of concrete. The post-tension members will not experience pre-stress loss due to elastic shortening of concrete if it is jacked simultaneously, if the pre-stressing reinforcements are jacked simultaneously or all at once. But then again, if the pre-stressing reinforcements are jacked sequentially, one at a time, individually. Therefore, pre-stress loss due to elastic shortening of concrete will occur. So you have to include that in the calculation of the total pre-stress loss being experienced by a post-tension member. So that is actually the summary of the losses being experienced by uh, a concrete element. Now, to further illustrate all of those pre-stress losses that I have mentioned, specifically when they will occur with respect to the different stages of pre-stressing, may I just illustrate here the pre-stressing operation again for pretension members, for pretension members first, and then later for post-tension members. So for pretension members, wherein pretensioning is done, again, let us just review what happens on pretensioning. So for pretensioning operations, there is a precasting bed first, wherein there are vertical bulkheads or walls that are placed at the ends of the precasting bed, and then the formworks will be set up here together with the steel reinforcements and the pre-stressing reinforcements. But then again, I will just omit the the illustration of the steel reinforcements for clarity of illustration of the other part of the pretensioning operation. So in addition to steel reinforcements, the prestressing reinforcements will also place here at a distance or at an eccentricity E from the centroid of the concrete element that we are pretensioning. So after the prestressing reinforcement is placed there, the hydraulic jack will uh, try to pull the prestressing reinforcement, thereby making it elongate and experience what we call the jacking force, or in this case, we will just uh, call it jacking stress. So at jacking operation, the pre-stressing reinforcement experiences the jacking stress F sub Pj. So that is actually the maximum stress that the pre-stressing reinforcement will experience all throughout the different stages of pre-stressing. And then after the pre-stressing reinforcement is jacked, the concrete will be poured, and then after some time, after the concrete already attained enough strength to resist the pre-stressing force that will be transferred by the pre-stressing reinforcement later on, then the pre-stressing reinforcement will be cut. But before the pre-stressing reinforcement is cut, as I mentioned a while ago, the pre-stressing reinforcement will experience pre-stress losses due to uh, relaxation, which has this magnitude. So this is the pre-stress loss due to still relaxation occurring from the time of jacking T sub 0 up to the time of transfer. So even before the pre-stressing reinforcement is cut, it already experiences pre-stress loss due to still relaxation. So you can imagine that the pre-stress force being transferred by the pre-stressing reinforcement to the concrete element is not actually equal to the jacking force or the jacking stress. Because again, like what I am showing here, the pre-stressing reinforcement already experience pre-stress loss due to the fact that it experiences relaxation starting from the time of jacking, which is this, up to the time of transfer, which is this. So at this particular stage of prestressing, the prestressing force is transferred to the concrete element. So that is when the at transfer stage commence or starts. So at transfer, the the prestressing force or stress acting on the prestressing reinforcement will be transferred to the concrete element. But if you are imagining that the magnitude of the prestress or the prestress that will be transferred to uh, the a transfer, so the prestressing force will be transferred to the concrete element with a magnitude of this equal to the difference between the jacking force or jacking stress and the prestress loss due to still relaxation occurring from the time of jacking to the time of transfer. After the prestress force is transferred to the concrete element, a transfer, the concrete element actually uh, experiences what we call elastic uh, shortening. So due to that elastic shortening, the prestress force or prestress being experienced by the prestressing reinforcement will experience additional prestress losses. And that additional prestress loss is actually what we call the prestress loss due to the elastic shortening of concrete. So when the prestress force is transferred to the concrete element, that concrete element tends to experience elastic shortening. And with that, that causes prestress loss to the prestressing reinforcement, which has a magnitude equal to this, which is again the prestress loss due to the elastic shortening of concrete. So later on, we will discuss how to specifically compute for this particular uh, prestress losses mentioned here. So after the concrete experience elastic shortening and consequently imposing what we call prestress loss due to elastic shortening to the prestressing reinforcement, we can now actually calculate the initial prestress that will be experienced by the concrete element at transfer. And that is what we call the FPI, the initial prestress. That is actually the prestress that we use that we uses to calculate the stresses acting on the concrete element at the early stages of prestressing. So then, after the prestressing force is transferred to the concrete element and the prestress loss due to elastic shortening already occurred, the tendency for the pretension beam or pretension member is that it will experience camber, which is the bending of the concrete element upward. And when it bend upward, it will be like it will act similar to a simply supported beam. So from being fully supported, it will now be forced to support its own weight. So therefore, it will now carry a uniform load, which is actually its own weight at this particular stage of prestressing, the initial prestressing stage at transfer. And then after some time, after after uh, the concrete element already supports its own weight, after transfer, additional prestress losses will be experienced by the prestressing reinforcement due to several factors such as the uh, steel relaxation. So again, after the prestressing force is transferred to the concrete element, the steel, the prestressing reinforcement, will again experience relaxation, which will result to prestress loss. So that magnitude of prestress loss due to relaxation usually occurs from time of transfer up to the time of stabilized loss, wherein the losses on the prestressing reinforcement already stabilized. So that is the additional prestress loss that is being experienced by the prestressing reinforcement after transfer. And then in addition to that, in addition to the prestress loss due to relaxation, the prestressing reinforcement will also experience prestress loss due to the creep of concrete. So again, that prestress loss starts to kick in starting from the time of transfer to the time of stabilized loss. So this particular prestress loss usually occurs on a concrete element due to the fact that at this particular point wherein uh, the concrete element already supports the remaining service loads that are intended to be carried by it, which are the superimposed dead loads and live loads. Because of that sustained loads, the concrete element experiences creep. So later on, we will talk about further what is creep. And because of that creep, uh, prestress loss occurs on the prestressing reinforcement because of the existence of that uh, creep that is being experienced by the concrete element due to the due to the sustained loads that are being supported by the concrete element, which are again the service loads. So in addition to the steel relaxation loss, loss due to the creep of concrete, also is being experienced by the pre-stressing reinforcement after the transfer stage. And lastly, last time dependent loss that being experienced by the pre-stressing reinforcement at transfer is the pre-stress loss due to shrinkage. So again, at this particular stage of pre-stressing at service load condition, we are already in service load condition after transfer. At that particular stage of pre-stressing, the concrete also experiences shrinkage, which produces pre-stress losses to the pre-stressing reinforcement, which has a magnitude equal to this. So that prestress loss due to shrinkage, again, just like the other prestress losses mentioned here, also starts to kick in starting from the time of transfer to the time of stabilized loss. So if you will deduct all of those additional prestress losses to the initial prestress we have here at transfer, we can have the what we call the effective prestress that will be experienced by the concrete element. So that is the cause, that is the reason why the the prestress force acting on the prestressing reinforcement uh, has a magnitude of equal to the effective prestress force, because it already experiences the effective prestress due to the reduction of the prestress losses to the initial prestress we have on a transfer. So those are the prestress losses being experienced by a pre-tensioned members at different stages of pre uh, pre-stressing operation. So now for the case of post-tension members, to illustrate the different pre-stress losses being experienced by post-tension members at different stages of pre-tensioning or post-tensioning, we will just use again the illustration a while ago, although this is not actually applicable for post-tensioning, because usually post-tensioning is being done by, or post-tensioning is being done usually at site and not on precasting plants. But just for the sake of illustration, we will just use again the illustration we used a while ago. So we have a precasting bed with vertical bulkheads, and the duct, for the case of post-tension members, the ducts will be placed at an eccentricity E from the centroid of the concrete element, and then after the duct or the ducts are placed together with the steel reinforcements, of course, but we just omitted the uh, illustration of the steel reinforcements for clarity. So after the placement of those ducts and steel reinforcements, the concrete will be poured to the formworks, and then after some time, after the concrete already attained enough strength, the pre-stressing reinforcements will be inserted to the duct for the case of post-tension members, and then it will be and then a hydraulic jack will pull the pre-stressing reinforcement, thereby making it elongate and experience what we call jacking force, or in terms of stress, we can call it as jacking stress. So that is actually the stress being experienced by the pre-stressing reinforcement at jacking. This is actually the jacking stage. But uh, on that particular operation, the pre-stressing reinforcement experiences what we call pre-stress loss due to friction, because in actual post-tensioning, usually the profile of the pre-stressing reinforcement is not like this, but usually a a profile which has a curvature. So due to that curvature, pre-stress losses due to friction occurs, because obviously there is as the hydraulic jack pulls the pre-stressing reinforcement, the tendency is uh, there will be a friction that will occur between the pre-stressing reinforcement and the sheeting or the duct that contains it. So because of that scenario, that phenomenon, the jacking stress will be reduced by a magnitude of equal to this, the pre-stress loss due to the friction. And in additional to that, if sequential jacking uh, is imposed here on the jacking operation, the pre-stressing reinforcement will also experience pre-stress losses due to the elastic shortening of the concrete. If sequential jacking is used, But if simultaneous jacking is used, therefore, we can just omit the pre-stress loss due to elastic shortening for the case of post-tensioning members or post-tension members. So after that, after the pre-stressing reinforcement is jacked, pulled with a certain magnitude of elongation, the pre-stressing reinforcements will be cut, thereby transferring the pre-stressing force from the pre-stressing element to the concrete element itself, wherein the transfer stage will commence or start. So at that particular stage of pre-stressing, wherein the pre-stress force is transferred to the concrete element, the pre-stressing reinforcement will now again experience additional pre-stress loss due to what we call anchorage seating. So that pre-stress loss due to anchorage seating is obviously related to the anchor itself. So the anchors are actually this illustration that you are seeing here, somehow similar to what is illustrated here. These are actually the anchors. Those are the reasons why the concrete is being compressed as the pre-stressing reinforcement tends to go back to its original length. So there are actually anchors there. So later on you will see what are those, what does those anchors actually look like. So because of those anchors, specifically the wedges inside the anchors, again later on we will study that further. Because of that anchor at this particular stage of pre-stressing, uh, the pre-stressing reinforcement tends to experience pre-stress loss due to that anchorage seating. So the magnitude of that particular anchorage loss usually varies from one manufacturer to another, because there are many variation of anchors depending on the manufacturer, and thereby produces different magnitude of anchorage losses due to the anchor. So that is the additional pre-stress loss that will be experienced by the pre-stressing reinforcement and transfer, as it transfers the pre-stressing force to the concrete element. So if you will reduce or subtract all of those pre-stress loss to the jacking stress, you will find the initial pre-stress that is usually used on computations of the stresses acting on the concrete element. So that is when the initial pre-stressing occurs at transfer after the pre-stress losses due to friction, elastic shortening, and anchorage were subtracted to the jacking stress being experienced by the pre-stressing reinforcement. And then after that, due to the existence of the pre-stressing force acting on the pre-stressing reinforcement, just like on the case of pre-tension members, the concrete element again will try to bend upward, thereby experiencing camber, making it look like a simply supported beam. So instead of being fully supported, the concrete beam now is forced to support its own weight at this particular stage, a transfer with self-weight. And then after that, after a transfer, wherein the superimposed dead load and live load are already imposed to the concrete element. So after transfer, so we are now entering the service load condition. After transfer, additional pre-stress losses are being experienced by the pre-stressing reinforcement. And first on the list is the pre-stress loss due to the relaxation of the pre-stressing reinforcement, just like in the case of the pretension members. So again, that pre-stress loss due to steel relaxation usually happens starting from the time of transfer, after the pre-stress force is transferred to the concrete element, up to the time wherein the loss is already stabilized. And then in addition to that, uh, pre-stress loss due to creep is also being experienced by the prestressing reinforcement after transfer because of the grip on the concrete due to the sustained load that it supports, which are the superimposed dead load and live load together with the dead load itself or the self weight. And lastly, the prestressing reinforcement also experiences prestress losses due to shrinkage of the concrete. So again, if you will try to deduct all of these losses that occurred after transfer to the initial prestress at transfer, you can get the effective prestress acting on the prestressing reinforcement after transfer. So that is the stress being experienced by the prestressing reinforcement after transfer, after all of the prestress losses already occurred. So that is a simple illustration of the prestress losses being experienced by a concrete element at different stages of prestressing.